Okay, so today we're going to learn how do we get something like log base 3 of 32 on the calculator, right, without doing it graphically. So in order to do that, we're going to learn the change of base formula. And in order to do that, well, what is the log base 2 of 16? So when you see that, you need to think 2 to the power of what is going to give us 16? So 2 to the 4th. On your calculator, work out log 16 divided by log 2. Log 16 divided by log 2. Remember to close parentheses when you do log 16. You gotta close that. And what do we get? 4. Oh, gotta change my mode. I was in rounding to 2 decimals, so it's just. So if you are doing the rounding stuff, when you're done doing a particular set of calculations, then change it back. Log base 525. Okay, 5 to the what will give you 25? 2. And work out log 25 divided by log 5. So calculator says 2. What is log base 3 of 27? 3. Right? In other words, 3 to the what is 27? So 3. What's log 27? Divided by log 3. So 3. We see a pattern here. So what do you notice about the values in each column? These guys, they're the same. So they are the same. They're the same. What's the relationship between the numbers in the first logs? Relationship between the numbers in the first logs, so the 2 and the 16 there, compared with these numbers here. Okay. So you can see the base ends up on the bottom, and the number, the value, we're taking the log base 2 of 16. So the log base 2 of 16 is equal to log 16 over log 2. And instead of writing that out, we'll just say that here. So the log base b of c is equal to the log base a of c over the log base a of b. So in all of these, we were changing it to a base 10 log. Okay, you're changing it to a base 10 log. Why would we change to a base 10 log? Or not base e? Like what would happen if we had said ln 27 divided by ln 3? What do you think is going to happen? Still going to get 3. So it doesn't matter what base you change to. Normally we change to base 10 because that's what our calculator does. That's what the log key does. What? Okay, move that. Move that. Canadian winter problem. We'll deal with it. Okay, so normally we change to base 10 because our calculator does base 10 logs, and we just saw we could change it to ln, which would be a base e log. So basically you can change to any other base. So log base b, whatever it was, log base 5 of 25 is the log base 10 of c, log of 25, over log of 5. All right, express each log as a quotient of logs. So quotient of logs means something over something, with a base of 5. So if we want to change this to base 5, it's going to be log base 5 of 125. So log, so just, this is on your formula sheet. Right? So all you got to do is match it up. So I've got log, that's a 3, that's a 125. they want a base 5 log, so I'm going to go log base 5. This goes up top, the 125, and on the bottom, log base 5 of 3. Okay, try the same thing with log base 25 of 200. Okay, so use the formula. You got the formula sitting there. You want to change it so that what do we got? So little a is 5. So you're going to rewrite them. That's on your formula sheet, right? Keep your formula sheet handy going forward. So all the questions that we do from this point going forward, you want your formula sheet with you, because then you'll know what's on the formula sheet, because this is what you're going to get on the diploma, right? And on the back side, we put the directing words, which you will not get on the diploma. All right, so what do we end up with? Log base 5 of 200 over log base 5 of 25. Express each quotient as a single log and then evaluate. So we've got log base 4 of 128 over log base 4 of 2. So if we look at this, it's like, here, this is the right-hand side. So you can write this as the left-hand side. Okay? So give that a shot. A little pattern matching, match it up. Say, okay, on the right-hand side, I've got this log base 4 of 128. Yeah, basically. So it becomes log. So the A's are gone, right? There won't be any 4's here. It's the B, so log base B, log base 2 of 128. So, okay, and then evaluate. So what is log base 2 of 128? Right? So in words, it says 2 to the power of something is 128. And the answer is 7. That's something you can do on your fingers. The powers of 2, so 2 to the 1, 2, 4, 8, 16, 32, 64, 128. On your calculator, 2, blah, blah, blah. But we'll learn how to use the calculator in a second. Log base 5 of 243 over log base 5 of 3. Okay, so we said the 5's are going to be gone. It's going to be the log, the bottom number is the base, and the top number is the value. So it's going to be the log base 3 of 243. Which is? So 3 to the power of 5. And a log, what's a log? What's a logarithm? It's an exponent. Right? What exponent? It's the exponent that we raised the base 3 to in order to get the number 243. Right? So a logarithm, when you write that expression, is an exponent. That's the number. Here, this is a base 10 log, but it's going to become log. So the 10's are gone. Bottom number is the base. Top number is the value. Log base 5 of 625 is 4. Okay, so you know it's a power of 5. You can play with them. Or, wait for it, part B. That's not in part B. Yeah, let's see where it is. Show you how to use your. Show you how to do this on the calculator. So another way. So let's say I did want to work out log base 2 of 128 on the calculator. Log base 2 of 128. So there's a couple of different ways. So one way, okay, well, one way to do log base 2 of 128 would be to change it to a base 10 log 128 over log 2. So for some of you, if you have the older calculator, this is the only way to do that. Okay, so if you have log base 2 of 128, you can type in log 128 divided by log 2. Hit enter, there's our 7. Okay, so on the TI-83s, that's the only way it's going to work. Higher up, if you go, which one is it? Alpha F2, number 5, you see log base. Okay, so if you don't see that, then you have to do it the way I just showed you. But if you go alpha F2 and you see log base, which is number 5, see it brings up log and it's going to allow you to put in the base. So we can go log base 2 of 128 and get there directly. Okay, so you got to figure out for your calculator, how am I going to have to do this? Okay, and if it's the first way, that's just this. That's just the base change formula. So it's given to you on the formula sheet. If you can't remember where log base is on the newer calculator that does it, it's on your formula sheet. Just use it off of your formula sheet. Use the formula sheet the way I showed you. Okay, you don't get log base.
Where's F2 on the
It's like at the top.
Oh.
That one there is F2. So when you hit alpha, the green key, then you're dealing with something that's in green.
Okay.
Okay, so that's why I say F2. When you hit something blue, you're dealing with any of the blue things here. If you're blue-green colorblind, then the top stuff is to the left and the bottom stuff is to the right. So if we wanted to work out this, and we could even do this, log base 5 of 243. So you could go alpha F2 log base. So log base 5 of 243. Oops. Be careful when you're doing that. Log base 5 of 243. Okay, go. Careful when you're doing that. 243 divided by, so we could do the actual expression, right? Which was log divided by alpha F2 log base 5 of 3. Okay, and we should get 5. So basically, older calculator, change it to a base 10 log. There's your formula, right? So if you have an older calculator, your formula sheet gives you how to do it, right? You can't just do log base. So if we wanted to evaluate log base 3 of 125, okay? So older calculator, you do this. You go the log of 125. So it's the log of the value divided by the log of the base, divided by log 3. Okay, and if you've got log base, then alpha F2, it's also in one of the menus, I just don't know which one. And number 5, and then put the base in, use the arrow to move over, put the value in, okay, and you get the same value. So regardless, you get the same value. You're saving maybe a couple of keystrokes one way over the other. So that's how you can use your calculator to work out any particular log to any base. Using logs to solve exponential equations. So this method needs to be used when we cannot get a common base. Okay, so if I had 3 to the x plus 1 was equal to 27, we can solve that algebraically, right? We would go 3 to the x plus 1 is equal to 3 cubed. We get a common base. We would set the exponents equal to each other, and we would solve. Right? So that would be one way of solving when we have a common base. We can't do that with 3 to the x plus 1 is 15. So here's the way that we're going to do it. We're going to rewrite this as a log. Well, actually, I'm going to show you 2 ways. So I'll show you the first way and then the way that we're just going to do it after that. So the power rule, right? Power rule says, so here's what we're going to do. We're going to take the log of both sides. Right? So just think log is an operation. It's like square rooting, right? I could square root both sides, right? I could square both sides. right? Nobody would blink an eye. Yeah, you square both sides, square root both sides, that's cool. We can take the log of both sides. Using the laws of logs, we can take this exponent and put it out front. Now, because it's a binomial, then we know that, hey, if we're going to do stuff with binomials, we're going to be moving stuff around. We got to keep that binomial in a set of parentheses, right? Got to put brackets around it. And that's equal to log 15. Then, to get x by itself, we're going to divide both sides by log 3. So x plus 1 will be equal to log 15 divided by log 3. And then we're going to subtract 1. So x will be log 15 divided by log 3 minus 1. Okay, so that's the laws of logs that allow us to do that, right? We take the log of both sides. We then use that law, the power law, to pull the exponent down, right? This allows us, because what we're doing here is we're solving for an unknown exponent, right? What's the exponent that we put in there that makes this true? And up until now, we have not been able to solve for an unknown exponent, right? We would have done this, but we would have graphed it. Okay, here's L1, here's Y1, here's Y2. Let's see where they cross. Okay, so if I work this out, we are going to have, so let's just clear that. So we're going to have log 15 divided by log 3. Okay, I'm going to do that first, right? And then just go minus 1. And we get 1.46. Okay, so rounded to the nearest hundredth. X is 1.46. All right, that's the big, long, involved way, right? Here's the other way. So from now on way, okay? You can choose either way. If you're solving something, just say algebraically determine, like show your work, you can do either way. So this is an exponential equation. We're going to write it in log form. Okay, so what do we say? Log, okay, what's the base? So let me just rewrite it here. Here's what we're starting with. Okay, log, what's the base? What is the thing I'm raising to the power? 3. So log base 3. What are we going to end up with? 15. And what's the exponent? X plus 1. So x is equal to log base 3 of 15 minus 1. Now, you have the older calculator. It's going to look exactly like this. This is what you're going to have to do. So from here, you're going to have to go, okay, it's log 15 divided by log 3 minus 1. On a newer calculator, okay, and that'll work on any calculator, right? You can do it that way. On a newer calculator, you can just go, so alpha F2 log 5 log base 3, 15, minus 1, and hit enter. There's the same answer. So you got to figure out whatever calculator you're using and will be using. You just got to figure out, okay, what do I do? Can I do the log base? And if you forget where log base is, just go back to the original, right? You can go back to I need to work out the log base 3 of 15. Okay, there's a formula on my formula sheet which will show me how to do it. If I change to a base 10 log, then it's going to look like this. Okay. And if you can just go straight to the base 3 log using your calculator, then that's the solution. So you can do it this way. Take the log of both sides, use the power rule to move that in front, divide both sides, right? Like isolate your x. Or take this expression, exponential, rewrite it in log form, and then just work it out. Your choice. I know which way I would choose. I'd probably do it this way. Solve. 25 equals 4 to the x. Okay, rewrite it as a log. So that's step one. Just rewrite it as a log. Log base something of something equals something. So change it from exponential form to logarithmic form. Log, what's the base? 4. Log base 4. Ooh, delivery.
I'm leaving my room.
I never told her. Probably noticed. Yeah. So leave the house. It's like, oh, they got in my pocket.
It's just like mass sweeping leave the house.
Yeah, right.
Like 3 times this guy left the house, took out my mask, I can drive back, they get it.
I mean, you should have both. So,
Yeah, I should have like some like.
hey, YouTube, it's 2020. Just to put this in a time context, is you could be watching this in 3 years. It's like, why are they talking about masks? You'll remember. If you're watching this in 3 years, you're old enough to know. Yeah, you're a kid. Log base 4 of what? Of 25, right? The value we want to get. So remember, a logarithm is an exponent, and that's the exponent, right? So when you write your log expression, it's equal to the exponent. Okay, bam, calculator. Right, one step, easy peasy. Do it the old way.
No. What do you want to do?
2 decimals. So for you, unnamed child sitting next to the window with the old calculator, here's how you're going to do it. You go log 25. So the log of the value divided by the log of the base. Okay, 2.32. There's a step we need to do first in B. What could we do? / should we do / must we do? Nope. What's a step that you could do to simplify this? Is there anything you can do to simplify this? Yeah. So divide both sides by 8. Okay. It's that. Now there's a reason. I'll show you both ways. I'll show you the other way to do it, which you should never do. But so what's 40 divided by 8? Yeah, 5. Okay, then we're good now, right? You know how to do this. So we have an exponential. We've got an unknown exponent. We rewrite it as a log. Our base is 3. We're going to end up with a 5, and the exponent that we're going to raise 3 to get the 5 is an x. And on our calculator, we just go. I'll put F2. The log base is somewhere else. Well, maybe I'll look for it in a second. Log base 3, arrow over 5, and 1.46. So the problem, if you don't divide both sides by 8, you got a problem, right? Because you've got 8 times 3 to the x. You can't just write that as a log, right? Because you got that 8 in front. So what would happen here, the thing you're never going to do, is you would take the log of both sides. Take the log. So the only way to do this would be you'd have to take the log of both sides. And then you would have to use your log logs here. So say log 40. So here you have to say, in there I got a product, right? It's 8 times 3 to the x. What is the log of a product? What can we do with the log of a product? So we can split it out into what? The sum of the individual logs. Okay? You are never going to do this. But you could write this as log 8 plus log 3 to the x. Okay? Then you would do this. Log 40 minus log 8 is equal to 3 to the x. And then you would go into logarithmic parts. Remember, you're never doing this, so if you write this down, you can erase this, cross it off, or just put an extra and say, don't do this. So we would say log base 3 of this, log 40 minus log 8, is equal to x. So if I did a log base 3, alpha f2, log base 3 of, and I go in here, log 40 minus log 8. Yeah, that'll do it. Nope. See, this is why you never want to do that. Log base 3. In theory, that should work, but it didn't. That's why you don't want to do that. I gotta pause there. In the grand tradition of carrying on with you still really should not have done this, but so log 40 minus log 8 we could work out. Log 40 minus log 8, just a number, right? So it's like 0.698997, and that's going to be equal to x log 3. Okay, because with power, you can pull that down. So x is equal to the 0.6989 divided by log 3. So if I take that and divide it by the log of 3, give up. I'm going to back things. All right, we've messed up how many times now? So I just did log 3. The division didn't hit. And hey, come on, deserves applause or pity, nothing else. Don't do that. Okay. So here you go. The moral of the story: you simplify the expression. Okay. Simplify the expression. So if there's a number sitting in front of, you definitely just do not want to use that law. You can't use it because you don't have a base, and definitely don't go, oh, it's like 24 to the x, right? You can't do that for sure. You can't just multiply that out. So you're not going to do this. Nobody is going to do this. Okay, so you're going to simplify the expression, divide both sides by 8, 3 to the x, change it to log form, plug it into the calculator, we're done. So, what are we going to do in C? We can divide by 100, right? So we get 1.02 to the x is equal to 5. Okay. Now at this point you shouldn't believe anything I say anyways, right? So, but here, let's do this. See, you know the 1.46 that we had? So that number's sitting here. So if we go 3 to the power of that number, right? And then multiply it by 8, then we should get 40. Okay, which we did, so that was all good. So here we got 1.02 to the x. So you can look at that. That would be a question, that's like a compound interest question, right? We have a principal of $100. We're getting 2% interest per year for X years. How long will it take before we get $500? That's a very useful thing, right? That's stuff that we had to solve in the last unit. We did solve exponential stuff, right? But we could never really answer the how much time would it take without using the graphing calculator. Now we can. So we're going to go log base 1.02 of 5. Okay, so it doesn't matter if the base is some number. Well, I think math is math. Math is math. No, log base. Maybe not. Nope. Nope. Maybe not. There we go. Log base. It's in the math menu. Okay, so if you go to math menu, then arrow up because it's near the bottom of the math menu. Okay, log base 1.02 to the of 5 is 81.27. 81.27. So if you had $100 and got 2% interest per year, it would take 81.27 years to end up with $500. All right, give this one a shot. So the starting point is Okay, let's change it to logarithmic form, right? It's an exponential, write it as a log. Right, so log, figure out the base. What's the value? That's equal to the exponent. Okay, and it was an expression, right? The x minus 1. Right, that's okay. So it just means to get x to isolate the x, we're just going to add 1 to both sides. So log base 4, alpha f2, back to that. Log base 4 of 40. Okay. Once you kick out of that, you can just go plus 1, right? And we can go straight to x. So x is 3.66. So what if I did 4 to the power of 3.66 minus 1? If I just put that in, am I going to get exactly 40? Why not? Okay, because we rounded, right? We used a rounded value. If I went 4 to the power of and pulled this whole number in, this whole number, and then subtracted 1 minus 1, what am I going to get? 39.999, which is 40. So rounded value, we're close, 39.95, okay. Close, within 100, we rounded to 100. Okay, give it a shot. So we're going to take an exponential, write it in log form. Right? We got to get good at that. Got to go both ways, writing exponential form in logarithmic form, writing logarithmic form in exponential form. Make sure you're doing the homework, you're practicing that. So the base 10 log, I can just write log. Okay. A little bit of algebra now. We gotta isolate the x. We gotta solve for x. So we're gonna add 1 to both sides, right? Then we're gonna divide both sides by 2. So x is gonna be log 200 plus 1 over 2. Okay. Now, if you're going to work that out on your calculator, you're going to have to put brackets around the log 200 plus 1. Okay, because you have to, this big division bar here means work out the top, work out the bottom. There's nothing to work out here, but work out the top, work out the bottom, then do the division. Okay, and so you have to tell your calculator that's how I want you to do it. So log 200, close the bracket, plus 1. Now another way to do that is just, hey, let's just work that out, and then we'll divide by 2. Okay, and we get 1.65. Okay, you want to try that, you go 10 to the power of 2 times, so 10 to the power of 2 times. Okay, now I can just go second function answer. Apparently I can't. Okay, 10 to the power of 2 times this number minus 1. Okay, and we should get 200. Okay, so you can check your answer. Okay, try the last one. I'm just going to pause this one. Nobody. So f, exponential form, 5 is equal to 15 to the power of whatever. Right? So if we want to solve for an unknown exponent, we do that by changing it to log form. So the log base, okay, whatever the exponent is on, that's your base. Log base 15 of 5, the value is equal to 3x plus 1. Solving this, we're going to subtract 1 and then divide by 3. On here, I can put a bracket for the top. So I'll put the top in brackets, right? We're going to go log No, can't do that. We're going to go log base. So log base 15 of 5 minus 1, close the bracket. There's my top, divided by, if there was something to work out here, I'd put another bracket down and then whatever expression was there. Okay, there's not, so it's just 3. Right. And we get x negative 0.14. Negative 0.14. Okay. That makes sense, right? Because 15 to the power of 1 would be 15. So it's got to be a number between 0 and 1, right? The exponent has to be between 0 and 1. 15 to the 0 would equal 1. 15 to the 1 would equal 15. So that 3x plus 1 has to be between 0 and 1. So x has to be negative, right? We got to reduce this. And again, you could check by going back to the original expression, go 15 to the power of, right? Pull the number in. So on the test, if you're going to do that, check at the end. Okay, wait till you're done. Right. So Monday, test is on Monday. So you can come at lunch, right? Start the test. So if you want more time, come at lunch, or come the last whatever 18 minutes of lunch, whatever that is. Okay. $200 is invested at 8% per annum compound. So you're not escaping compound interest questions. Okay, they're back. $200 is invested at 8% per annum per year, compounded semi-annually. Algebraically determine how many years it will take for the investment to at least double in value. At least double. So if it's $200, we want it to be worth at least what? 400. So our formula for compound interest. So we want it to be worth 400. It's worth 200. Our investment, 8% is 0.08. Compounded semi-annually, you have to divide the interest rate by 2. Determine how many years it would take. So if I write this as just plain old x, it will be the number of semi-annual periods, right? In which case, when we get x, so if it said x was 5 semi-annual periods would be 2.5 years. We'd have to divide it. Or I can say to the power of 2x. Okay, so I'm going to divide the interest rate by 2. I'm going to multiply the number of years by 2. So when we solve for x, we will end up with the number of years. Okay, if instead of 2x you wrote x, you wouldn't have years, you would have semi-annual periods, and then you would have to divide that by 2 to change it into years. Okay, so either way, there has to be some modification. What's step 1? Okay, get rid of that 200. Okay, we have learned painfully, without practicing it ahead of time, how to mess it up royally by not doing that. So isolate the exponent, the exponential part of the equation. Right? So it's just 1.04 to the 2x. Okay, so you know how to do this now, right? Now it's a log. So log base 1.04 of 2 is equal to 2x. So x will be the log base 1.04 of 2 divided by 2. On the calculator, I would probably just work out the log first, right? What's log 1.04 of 2? Hit enter, and then divide that by 2. So log base 5, 1.04 of 2, hit enter, then go divided by 2. So 8.84 years. Well, 8.3, that's the dot. So that would be 9 years. Okay. So how many years to at least double? So it would take 8.8 years, or 8.84 years, right? But it's, how many years? Well, of 9 years. We take 9. So at 8 years, it won't quite be double. It will double 0.8 of a year into the year, right? But we're just going to say for the nearest whole year, we take 9 years to double. Math is here. Math is nothing made up. It's a radioactive substance that has a half-life of 3.14 days. If a science lab started with 500 grams of mathozole and after a number of days later only had 90 grams remaining, algebraically determine how many whole days it took to reduce to at most 90 grams. Okay, so it's got to be 90 or fewer grams, right? It's got to weigh 90 or less. So when we find our days, we're just going to take it up to the next whole day. So our formula, and generally you'd probably be given this, so the half-life. So now we use half-life. A is equal to so the amount we end up with is equal to the amount we start with. The base is 1/2 because we're doing a half-life, so it's going in half. T is the amount of time that it's going to take, and H is the half-life. Okay, H is the half-life. Okay, and so they gave us the half-life, right? So we got to know what goes in where. So we want to end up with 90 grams. We started with 500 grams. We don't know how much time, but we do know the half-life is 3.14. And if 3.14 is in days, then when we solve for T, it's going to be in days. They have to be in the same units. So T and H have to be in the same unit. So if it's hours, then it has to be hours. So if it said hours, but it gave you days, you would multiply by 24 to convert it to hours. Right? Just make sure the units are the same. All right, so we're going to go 90 divided by 500. So does that work out to some nice number? 90 divided by 500. 0.18. Okay, that's cool. Okay. So 0.18. Okay, so now we change to log form. So it's going to be log base something equals something. So rewrite the log, or rewrite it in logarithmic form. So log base 1/2 of the number, we're going to get 0.18. Okay, and you can write that as 90 over 500, right? You go log base 1/2 and bracket 90 divided by 500 bracket equals T over 3.14. Isolate T if you like, so it's 3.14 times log base 1/2. Let me just straight work that out. Move that over. 3.14 times log, need my log base. Log base 1/2. So you can put 1/2. I'm just going to go with 0.5. Right. Okay. But you can do 1/2. Back it up. Here, I'll back up. Put in 1/2. Use my fancy calculator, right? 1, 2. So there's log base 1/2 of 0. Or here you can really even just put 90 divided by 500. Right there. We didn't need to work out. It's not even the point, 90 over 500 worked out nicely. It was 0.18. That's exact. There's no rounding going on. We set the calculator to float. If it was not exact, then do it using the number. Hit enter. We get 7.77. How many whole days? So 7.768. So how many whole days?
8 days.
8 days. We take 8 whole days. So on the 7th day, when we stop and rest, there would be more than 90 grams. Right? The 7th day. And we want to have that most 90. So we have to go one more day. Well, because it'll be, 7/10 of the way through the next day or 8/10 of the way through the next day that it will have the 90 grams. All right, equal time to science is math. Science Z is a radioactive substance. There was 1,000 grams to start. Algebraically determine the half-life if there was about 200 grams remaining after 21 days. All right, start with this. And sometimes, if I know that somewhere else on the test I've used the compound interest formula or something, then I may not give it to you later on. It's no big requirement, right? It's just sort of like, hey, look back a couple of pages, you're going to find the formula you need. So be aware of what's on the test as you go through it. All right, so A is equal to A naught. Still a half-life question. T over H. 200 grams remains. So with the half-life question, the amount remaining always has to be smaller than the starting amount, right? If you write down your equation and say this is bigger than this, it's like, no, you got your numbers reversed, right? It's a half-life. 21 days over H. So what we don't know is the half-life. Okay. What's H? Step 1, do what? Divide 200 by 1,000. Can't do anything with log. You can't do any of the log stuff unless you just have an exponential. You cannot convert this to logarithmic form. Okay, you already saw me try and fail 3 times. It's like, if I couldn't do it, pretty good chance you're not going to be able to do it. And we don't want to do it. That's not the way to do it. Right? We just simplify. So 200 divided by 1,000 will be 0.2. So log base 1/2 of 0.2 is equal to, that's 21, is 21 over H. So when you get an expression that looks like this, you want to solve for H, just interchange these two guys, right? Or multiply both sides by H and then divide both sides by this log 1/2. So H, let's do this, we'll multiply. H times log base 1/2 of 0.2 is equal to 21. Okay, so basically we multiply both sides by H, then divide both sides. So 21 divided by log base 1/2, 0.2. Get your H, and then round it to give your final answer. So, on a written question, show what you're getting for H, and then state your final answer, right? Okay, so 21 divided by log, not that log, okay? Log base. For a half, I'm just going to put 0.5. 0.5 is half. 0.2. Hit enter. 9.044. We're just going to go with 9 days, right? It says we get approximately 200 grams. So there might be a smidge over 200 grams, but, in this case, normal rounding applies. It's 0.04 of a day, or 100. Not that much. Any questions?